Okay, so number 36 says the voltage V of an audio system's speaker can be represented by the equation V equals 4 times the square root of P, where P is the power of the speaker. An engineer wants to design a speaker with 40 watts of power, or 400 I mean. So that means P equals 400. What will the voltage of that audio system be? So I just need to take the 400 and plug it into the formula. What is the square root of 400? 20. So this is going to be 4 times 20, which means the final answer is 80 volts. You got 10,000 volts? Okay, that's close. You'll make a really great electrical engineer someday. You got 10,000? Okay. You guys understand? Good job. You guys understand how to do it now? Okay. Uh, I don't, because I did the square root of it. So the square root of 400 is 20, so now the square root is gone. Okay? Oh, no, it's a 4 times. Yeah, good. Okay, shh, shh, shh. Did somebody say 40 something also? Which one? 40 what? 44 was not assigned. 45 was assigned. Okay, 45. Okay, good. Is each equation always, sometimes, or never true? So we talked yesterday about how you do roots of exponents. Does anybody remember how you take the root of an exponent? You divide it, yeah. So what is the number that's here that's just, yeah, okay. So 4 divided by 2 is 2. So this one is always true, okay? So you have to be careful though. 48, 3 divided by 3 is 1. So the cube root of x cubed is x. But what does this mean? What do the lines on there mean? Absolute value, right, which makes it positive. And what we talked about on Tuesday when we were going through this is the cube root of a negative number can be negative, okay? So this is, yeah, only sometimes true. This would be true when the number is positive. Well, you don't know that because it's just x, so it could be anything you want. So for example, if x equaled 2, then 2 cubed is 8, right? And the cube root of 8 is 2. So that's a time when it's true. But if x equals negative 2, then x cubed is negative 8. And the cube root of negative 8 is negative 2. And that doesn't work because the absolute value of negative 2 would be positive 2, not negative 2. Okay? So this is sometimes, but not always. Okay? Zoe, what you got going on there? What you doing? What is it? Okay. Did you not have questions on these? Okay. Anybody else? 30? Okay, 30. So we talked about this. We did this example in the notes. But in the notes, I was giving examples of when the score is this, how do we change it for what goes in the grade book. This question is going the other way around. If they want to get a 70 in the grade book, what score do they have to get on the test to be able to do that? So how would you solve that for R? Divide by 10. So if I divide both sides by 10, then 7 is equal to the square root of R. So what does R equal? 49. So if you got a 49 on the test, the nice teacher that you have would take the square root of 49, which is 7, multiply that by 10. So your previously failing score of 49 would jump up to be 70. What I do when you guys take a test is your last test was out of 35. 49 is the answer to life, the universe, and everything. No, because nobody got a 1 on the test. The test you guys took a week or so ago. Anyway, other questions? 33? 39? Okay, 39. So when you're doing these things with fractions, you just do them as two individual problems. So what's the cube root of 8? 2. And what's the cube root of 216? Yeah, 6. So that would be 2 over 6, which reduces to 1/3. The other way that you could do that, no, that wouldn't work. Never mind. No, and that's what McKenna was asking too. We took the cube root of it, so that's gone now. So like if I left the cube root thingy here, that's not, I did the cube root. So on 42, okay, so the 4th root of 16 is 2. The 4th root of c to the 4th is c. Done. No 4th root on, I did the 4th root. I'm done with that. So if I put like this under a 4th root, then that'd be like, oh, now I have to take the 4th root again. And then I'd have to do it again and again and again, and it would never end. You'd be spend an infinite number of time working on that one problem. You only do it once. And since it's done, you don't put that there. Okay? All right, anything else? That's the bulk of it. Okay, can I get those assignments from you, please? Radical, yeah, with math is to learn how to do math with these creatures that we just learned about on Tuesday. So we are eventually going to multiply, divide, add, and subtract. We're going to start with multiplying today. I think that's as far as we're going to get with this if my first period class is any indication. And then we'll do dividing tomorrow. And then next week we will work on adding and subtracting. And then the ultimate goal almost always is to get to where you can use this math to solve some equations that involve this stuff. Yeah. They are, yes. No, those are the only 2 periods that are the same that I teach. No, that I do teach this year. No, all my other ones, there's only one calculus class, there's only one bridges class, there's only one math analysis class, there's only one pre-class. I do. With me, yeah, it'll be fun. I know there's a lot of you in here that like it if I like write down specifically the steps. So for multiplying radicals, you can do it if either one of 2 things is true. The roots have to be the same. Or the numbers under the roots have to be the same. And I know that without any... Okay, so for example, can you multiply the cube root of 6 by the square root of 2? No. The answer to that is no, because the roots are different. This one is a 3 and that one's a 2, even though it's not written. We just assume there's a 2 there. And the numbers underneath the roots are different. One is a 6 and one is a 2, so you can't do that. Okay? All right. How about this guy right here? Q. Yes. Because they're both, good job, because they're both cube roots, you can do it. Okay? So the way that you do it is you multiply the numbers together that are underneath the cube root. So -4 times 2 is -8. And then if you can, you figure out what the cube root of -8 is. What is the cube root of -8? -2, not 2. Nope, doesn't have to be an I, because -2 times -2 is 4, times -2 is -8, so it works out exactly. You don't need a weird thing in there. That's only for square roots of negative numbers. Cube roots are okay. Okay, maybe I don't want to answer them.
Okay, but what if you got negative, how did you get negative 2?
Because I know that 2 times 2 times 2 is 8. So that means that negative 2 times negative 2 times negative 2 is negative 8. So when it says cube root, you're looking for a number, the same number multiplied 3 times in a row gives you negative 8.
What if, so for the 3, if you had negative 3 for your cube root and then positive 3, could you still solve it?
Okay, so Zoe asked if this was the cube root of negative 3 times the cube root of 3, could you still solve it?
On the outside.
Oh, like this is a negative? Oh no, we're not doing that. No. No, but we're not there yet. Yes, yes. But we're not going to mess around with that.
But if you ever do go into roots,
In that case, the roots would be different and the numbers would be different, so it would be cannot be simplified. Yeah. Okay. Brianna? You raised your hand? Okay. All right. How about this guy right here? Can you simplify the 4th root of 7 times the 5th root of 7? Yes, because why? Because the number underneath the root is the same. Okay, now we're not going to get into right now how to do that. We're going to get into that later in the chapter. But for right now it says, can you simplify? So the answer to that is yes. Okay. Yeah, so I'll give you a little backstory here. First of all, if I go x squared times x to the 5th, what do I get? X to the 7th. So what you're telling me that I do is I leave the base alone and just add the exponents, right? The x didn't change. I just went 2 plus 5 is 7. Okay, so to simplify this, I would have to write it first as exponents. So the 4th root of 7, we're going to talk about more later, is 7 to the 1/4. Okay, the 5th root of 7 is 7 to the 1/5. Okay, good. So to simplify this, I would just add the exponents. So 1/4 plus 1/5 is 9/20. So the answer would be 7 to the 9/20. I know that's kind of over your heads a little bit. We're going to get into that later. Okay, if you're confused, don't be mad at me. Be mad at Sydney. It's her fault.
yeah. Sydney.
And she's making it worse. Go ahead. No, it's not. Because when you're getting the common denominator, you have to multiply that by 5, and you have to multiply that by 5. And then you have to multiply this by 4, and you multiply that by 4. So you're multiplying the bottoms and you're adding the tops. The only times, though, that works is when it's a 1 on top of each of them. But it is a handy little trick to very quickly add together those fractions. So if you wanted to add 1/3 plus 1/7, it would be 10 over 21. Does that make sense? Okay. Yeah, that's easy. Okay, can you simplify the product of the 5th root of negative 5 times the 5th root of negative 2? Yes, how come? Because what's the same? The roots are the same. Yeah, so this would work out to be the 5th root of 10, which we can't simplify any further than that, but you could do at least that much. Okay? Okay? Uh-huh. So like you want to make this a negative 5?
No, not the outside.
Okay. That's okay. Then this would be the 5th root of negative 25. You either need the little numbers to be the same or the big numbers to be the same. Doesn't matter. Yeah. Zoe, this is my favorite version of you.
Thank you.
I don't know where you've been all year, but I like this one. Come back again tomorrow. Oh no, you won't be here tomorrow. You're going. Okay, so the next thing that we're going to work on then is simplifying higher roots than just square roots, okay? I'm sure that you guys all remember simplifying square roots. So like if I ask you to simplify the square root of 24, you would say, what's the biggest number that I know the square root of that goes into 24 evenly? 4. So I can rewrite this as the square root of 4 times 6. And then the square root of 4 is 2. So that comes out. And so my final answer would be 2 squared root of 6. We've done that in this class a lot. Pretty much every time we use the quadratic formula, we end up doing that step right towards the end. Okay? That, there are no, oh, right here? Yeah, 54x to the 5th. Okay? That's not so bad because you guys mostly know your square roots. 4, 9, 16, 25, etc. It's a little bit trickier when you're doing cube roots because you need to know numbers that are perfect cubes. And so for that, you might want to write down these numbers here. Just this part right here, okay? So the numbers that you know the cube root of, or that you should know the cube root of, 8, the cube root of that is 2. The cube root of 27 is 3. Yeah, the cube root of 64 is 4, and so forth. That's a 125. I don't know, can you guys see that? Yep, that's what Callista just decided to do. Yeah, if you're taking a picture of that as an easier way to take notes, then go for it. I don't want to be in it. Okay, so 8, 27, 64, 125, 216, those are numbers that you know the cube root of, okay? So when we're simplifying cube roots, you're not looking for one of these numbers that goes in there evenly. You're looking for one of these numbers that goes in there evenly. And so that's a little bit trickier because you guys aren't as familiar with these numbers as you are the other ones. So if I want to simplify the cube root of 54x to the 5th, what is the biggest number that you know the cube root of that goes into 54 evenly? What's the biggest number from that list
8.
that goes into 54 evenly? Okay, 8 is a winner. No, actually it's not. 8 does not go into 54. 9 goes in there, but I don't know. Okay, stop. Stop. These are the only numbers that we know the cube root of, okay? 10 is no good. 6 is not. These numbers right here, Abby. Okay, right. So the biggest number from that list that goes into 54 evenly is 27. So I'm going to rewrite this as 27 times 2, okay? Now I need to break down the variable. And what we talked about on Tuesday was that the variables are actually pretty easy because you just have to divide this number by this number. So to figure that out, I'm going to ask a slightly different question. I'm going to say, what's the biggest number less than 5 that 3 goes into evenly? 3. So I'm going to rewrite x to the 5th as x to the 3rd times x squared, okay? Now, right now what I'm doing, you might be going, what in the world is happening? But, oh yeah, but what I want you to understand right now is, do you understand that 54x to the 5th is the same as 27 times 2 times x to the 3rd times x squared? You understand those are the same? Okay, now we're going to start doing cube roots. What is the cube root of 27? 3. So I'm going to take that and move it to the outside as a 3. Okay? What is the cube root of x cubed? X, because 3 divided by 3 is 1, so I'm going to take that and move it to the outside as just an x. Okay? The stuff that's left over, I don't know the cube root of, so it stays where it is as 2x squared. The cube root of x cubed is x because if I divide this exponent by this root, I get 1, which is just x. Yep, absolutely. I got like 2 more. Yeah. I took this number right here and I broke it down into 3 plus 2 equals 5. And the reason why I did a 3 is because 3 is divisible by 3. If this had been like a 7, I would have broken it down into a 6 and a 1. 6 because 6 is divisible by 3, and 1 because that's what's left over. Okay? All right, let's play again. Let's figure out what is the cube root of 128x to the 7th. Okay? So, same question as before. What's the biggest number that you know the cube root of that goes into 128 evenly? And again, those numbers are 8, 27, 64, 125, and then there's more. But what did you say, Josh? 64. Okay, so I can write 128 as 64 times 2. Okay? Now I need to know it's not always going to be times 2. That's just they're trying to start you out with easy ones. 128. Yep. Okay. In a second. Yeah. Then I need to look at the x to the 7th, and I want to change that 7 into a number that's divisible by 3. 6. Okay. So I'm going to make that into an x to the 6th. What's left? Yeah. X to the 1st or just plain old x. Okay. You don't have to write the 1 there. I'm just going to write it there so that you guys can see 6 plus 1 is 7. Yes, the exponents add together. Because 6 is divisible by 3, so I can now say this is going to come out as an x squared. So I'm getting that out of the cube root. The more I can get out of the cube root, the better off I am. Okay? What's the cube root of 64? 4. So I can get that out of the cube root also. Okay? Now all that's left under there is a 2 and an x. So this is my final answer. Okay, Vili? Yep, yep, the exponent by the root, yeah. Anna? I'm with you. Like, what is your definition of simplify? How is this simpler than that, right? What is with these math people? Yeah, if I could do the one eyebrow raise right now, I would be doing that as well. Right, okay? Again, as I've said before, I've been hired by the state of Washington to teach you the song of my people, okay? I didn't get to write the song myself, but I just have to teach you the lyrics, okay? Okay. Time's up. All right, so now let's put those two ideas together. Let's start with square root of 72 x cubed y squared times the square root of 10 xy cubed, okay? To simplify those things, since the roots are the same, we can multiply them together, okay? This is a square root, and this is a square root. That was the first thing that we talked about, so I can multiply those together. So 72 times 10 is 720. X to the third times x is x to the x to the third times x is what? X to the fourth. And then, yeah, because don't forget this is y to the first, so you have to add that on there. And then y squared times y cubed is y to the fifth. All right, now we are ready to simplify. You have to pay attention to what the root actually is. So this time I'm doing a square root, which in theory should be a little bit easier. I went 2 plus 3. What is a number that you know the square root of that goes into 720 evenly? 9, okay? So let's rewrite this as 9 times 80. Higher would work better. What? We can just do 9. Yeah, it does. 720 divided by 9 is 80.
Oh, I just took the square root.
Oh, no. Okay, and then hold on. What do I have to do with this x to the fourth? I'm going to end up dividing it by 2, and since 4 is divisible by 2, I don't have to change it. What do I have to do with the y to the fifth? Good. I'm going to make that y to the fourth times y. Because, Ashlyn, I just need these exponents to be divisible by 2. And 4 already is. So I don't have to change it. Right. Okay, now we can do better with 80. What's a number you know the square root of that goes into 80 evenly? We could do 4, 16. Okay, let's rewrite this as the square root of 9 times 16 times 5 times x to the 4th times y to the 4th times y. And now we are ready to go. Okay? No kidding. So now we're ready to pull out square roots. What's the square root of 9? 3. What's the square root of 16? 4. Ashlyn, all I did is I just wrote 80 as 16 times 5. Okay, what's the square root of x? Shh, 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 shh. Just hang, just, shh, nope. Shh. Let me finish, and then I'll take your questions, okay? What is the square root of x to the 4th? X squared. What is the square root of y to the 4th? Y squared. And then what's left underneath the square root is a 5 and a y, okay? What am I going to do with the 3 and the 4? Multiply them together. So my final answer, which some people would argue is not any simpler than what I started with, is 12x squared y squared times the square root of 5y.